So hello everyone. We are here with the most important questions from limits and derivatives chapter. So the first question I have selected is limit limit x tends to 0. We have um, cos 2x x tends to 0, cos 2x minus 1 divided by cos x minus 1. Yeah, so if you plug in the value of x over here, we get cos 0, which is 1. So 1 minus 1 is 0, and over on the bottom also we get 0. So this limit is of the form 0 upon 0. So what do I do over here? I'll apply the trigonometric formula. What is cos 2x? It can be written as 2 cos square x minus 1 and again minus 1, and this is cos x minus 1. Now see, this can be written as limit x tends to 0, 2 cos square x minus 2 divided by cos x minus 1. Again, this can be written as limit x tends to 0. If you take 2 common, we will have cos square x minus 1 divided by cos x minus 1. Now if you factorize this stuff over here, we will have 2 times cos x minus 1 into cos x plus 1, and on the bottom we'll have cos x minus 1. So we can cancel this stuff out over here. So we'll get 2 times cos 0 plus 1, which is 2 times 1 plus 1, which gives me 4. Okay, so you can pause and see the uh, explanation. We'll move to the next one. We have limit x tends to 0, cosec x minus cot x. So see, cosec x can be written as 1 upon sin x, and cot x can be written as cos x upon sin x. Now if we apply the formula over here, if we just subtract this 1 minus cos x, and this will be sin x. Now see, you should know that 1 minus cos x is 2 sin square x upon 2, and then sin x can be written as 2 sin x by 2 cos x by 2, right? So I can cancel the 2's out here. Okay, so we will have limit x tends to 0, it will be sin x upon 2 divided by cos x upon 2. This gives me limit x tends to 0, tan x by 2. Okay, now if you plug in the value of 0 over here, we will get tan 0, which is simply 0. Okay, moving on to the next question. We have limit x tends to 0. We have ax plus x cos x divided by b sin x. So the idea over here is to divide both top and bottom by x. So if you do so, we will have a plus cos x, because the x cancels out, and this is b sin x upon x. Basically what we are doing, we are dividing by x both top and bottom. Okay, so you would know that this will become a plus cos 0, and sin x upon x when x tends to 0 is 1, so this is b into 1. So this will be a plus 1 upon b. Moving on to the next question, we have limit x tends to 0. Okay, this is sine of ax plus bx divided by ax plus sine bx. Again, it's the same idea. Basically we will have to divide both top and bottom by x. So we will have sine ax upon x plus bx upon x. This is ax upon x plus sine bx upon x. Now you would know that to evaluate this limit over here, I'll need to have sine of, this is ax by x, I'll multiply with a over here and there. Likewise, x and x cancels out to become b. Again, x and x cancels out to give me a, and over here I'll multiply with b both top and bottom. So this will be b into 1. So this gives me a into 1 plus b divided by a plus b into 1. So I'll have a plus b divided by a plus b, which gives me 1. Moving on to the next question. Next question is an important question. We have limit x tends to pi by 2. Limit x tends to pi by 2 tan of 2x divided by x minus pi by 2. Now these limits are called limits using substitution method. So what are we gonna do? We will let x minus pi by 2, more often than not we let the denominator as h. Now you tell me, when x tends to pi by 2, okay, when my x tends to pi by 2, h will tend to 0, right? Okay, because when you plug in the value of x as pi by 2 here, pi by 2 minus pi by 2 is going to give you 0. Okay, so see, we are substituting, so now my new limits should be completely in h form. So this x minus pi by 2 is equal to h. I can basically write this as x equal to pi by 2 plus h. Okay, so what am I gonna do is, this limit will become limit x tends to 0. This is tan of 2. Now this x can be written as pi by 2 plus h. Again on the bottom, x minus pi by 2 is h. So this will give me limit h tends to 0. This will be tan of, if we distribute the 2 inside, we will have pi plus 2h. On the bottom I have h. Now you would know that tan pi plus theta is tan theta. So this is limit h tends to 0, tan of 2h upon h. Now you multiply both 2 on the top and bottom. So this will be 2 into 1, 2. Alright. So let us take another question involving substitution. Just a moment. Yeah, so if we take this question over here, let's say limit x tends to pi by 2. Limit x tends to pi by 2, 1 plus cos of 2x divided by pi minus 2x whole square. So what am I gonna do is, again I'm gonna substitute the denominator as h. So let pi minus 2x is equal to h. So when x tends to pi by 2, h will tend to 0, right? Also I can write from here pi minus h is equal to 2x. Okay, so I'm gonna put that back in. So this will be limit h tends to 0, 1 plus cos of 2x becomes what? Pi minus h. Okay, now pi minus 2x is simply h, so this is h square. So this will be limit h tends to 0, 1 plus cos pi minus h is 1 minus cos h, and on the bottom I have h square. So this will give me limit h tends to 0, you would know that 1 minus cos h is 2 sine square h by 2. Now on the bottom you need h by 2 ka whole square. That will be what? H square by 4. So I have to multiply with 4 both top and bottom. Now this can be written now as limit h tends to 0. 2 upon 4 is 1 upon 2, and this is sine h by 2 divided by h by 2 whole square. So this becomes half into 1 whole square. Basically half is the answer. Okay, so moving on to the next one, we have limit x tends to pi by 4, 1 minus tan x upon x minus pi by 4. So what I'm gonna do is I'm gonna let the denominator again is h. So let x minus pi by 4 equal to h. So as x tends to pi by 4, h will tend to 0, right? So my limit will become limit h tends to 0. This is 1 minus tan of, in place of x I'll write pi by 4 plus h. On the bottom it is simply h. Now we will have to apply tan a plus b formula over here. Okay, so this will be 1 minus tan of pi by 4 plus h, I mean tan h, and this will be 1 minus tan of pi by 4 tan h. On the bottom I simply have h. Now this is limit h tends to 0. I have 1 minus 1 plus tan h and divided by 1 minus tan h. And over here I simply have h. Now this is limit h tends to 0. If you take the LCM over here, we will have 1 minus tan h into h. This is 1 minus tan h minus 1 plus tan h. So I'm gonna get, this will become limit h tends to 0. 1 and minus 1 will cancel out. Okay, I'm gonna have minus 2 tan h. This is 1 minus tan h and h. Now I can make tan h by h as 1. Okay, this is gonna give me minus 2 divided by 1 minus tan 0, which is 0, and this tan h upon h becomes 1. So minus 2 by 1, minus 2 is the answer. Okay, okay, so let's take another limit. So limit, I have theta tends to pi upon 6. Okay, we'll have cot square theta minus 3 divided by cosec square theta minus, oh, this is cosec theta minus 2, beg your pardon, this is cosec theta minus 2. Now see, we have this formula over here, 1 plus cot square theta is equal to cosec square theta. So this is going to give me limit theta tends to pi by 6. In place of cot square theta, I'm going to write cosec square theta minus 1. So cosec square theta minus 1 minus 3 divided by cosec theta minus 2. So this is going to give me, since in limits where we can use formulas, we did not use the substitution, right? Because I would imagine you can see what I'm going to do over here, right? So I can simply factorize the numerator now. Okay, a square minus b square. So I can write this stuff as limit theta tends to pi by 6. This becomes cosec theta minus 2 into cosec theta plus 2 divided by cosec theta minus 2. So we can cancel this stuff out here. Okay, and I'm gonna have what, limit theta tends to pi by 6. This will be cosec of pi by 6 plus 2. Now cosec pi by 6, sin pi by 6 is half, so cosec pi by 6 will be 2. So 2 plus 2 gonna give me 4. Okay, so 4 is the answer, right? Alright, now we have some formula based limits. Okay, so you would know that limit x tends to a x to the power n minus a to the power n upon x minus a. This stuff is basically n a to the power n minus 1. Now we have a question over here. The question is limit x tends to 9. Okay, we have x tends to 9, x to the power 3 upon 2 minus 27 divided by x minus 9. So see, if you compare it with the formula, even if you don't know what is 27 in terms of 3 by 2, you can simply see now we have x minus a on the bottom. Obviously 27 will have to be 9 to the power 3 upon 2, right? So this is x to the power 3 by 2 minus 9 to the power 3 by 2. Because you see 9 can be written as 3 square and 2 cancel, 3 cube will give me 27, right? Okay, so if you apply the formula over here, you see in place of in place of n I have 3 upon 2. So this is gonna give me 3 by 2 into a to the power 3 by 2 minus 1, right? As you can see, 3 by 2, okay, and a to the power n minus 1. So 3 by 2 into 9 to the power 3 by 2 minus 1. So this will be 3 by 2. This is 9 is 3 square. 3 by 2 minus 1 is 1 by 2. Okay, so 3 by 2 into 2 and 2 cancel. I can simply cancel that, right? So we are gonna get what? We are gonna get this as 3, which is 9 upon 2. Okay, moving on to the next one. We have limit x tends to 3, x to the 5 minus 243 divided by x square minus 9. Now you see what I can do over here. I can write 243 as 3 to the power 5, and then this is x square minus 3 square. Now we have a formula, limit x, just the formula we discussed, x tends to a, x power n minus a power n upon x minus a is n a n minus 1. So basically I need x minus 3 on the bottom of both the numerator and denominator. So I'm going to divide both top and bottom by x minus 3. Okay, so we are going to get limit x tends to 3, x to the 5 minus 3 to the 5 upon x minus 3, and on the bottom I will have x square minus 3 square divided by x minus 3. Okay, so this is going to give me 5 into 3 to the power 5 minus 1, and this will be divided by 2 into 3 to the power 2 minus 1. So this becomes 5 into 3 to the power 4 divided by 2 into 3. So this is 5 by 2 into 3 cube. Okay, 5 by 2 into 3 cube. So evaluating this, 27 times 5 is going to give me 135. So 135 by 2 is the answer. Alright. Okay, taking another example, limit x tends to 0. Okay, 1 plus x to the power n minus 1 divided by x. Okay, see, can I write x as, you tell me, can I write x as 1 plus x minus 1? You know, of course I can write. Now see, if you let 1 plus x is equal to h, okay, so when x tends to 0, h will obviously tend to what? 1, you know, because if you plug in x as 0, 1 plus 0 is what? 1, you know. So this stuff over here will be limit h tends to what? 1. This will be what? H to the power n minus 1 divided by h minus 1, right? Okay, now see, this is simply what? My formula. Okay, so where 1 can be written as 1 power n, so this will be n into 1 to the power n minus 1, which is simply what? N. Okay, acha. So let us take another question of this type. We will have limit x tends to what? X tends to a. Okay, limit x tends to a, x plus 2 to the power what 3 upon 2 minus a plus 2 to the power 3 upon 2. Okay, and on the bottom I have what on the bottom I have x minus a. Okay, what I can do over here, you see, this is limit x tends to a. This is x plus 2 to the power 3 by 2 minus a plus 2 to the power 3 by 2. What I'm gonna do is I will write this as x plus 2 minus a plus 2. Now if you compare it with your formula, okay, in place of a I have a plus 2 over here. Okay, so this is just gonna be what? This is gonna be 3 by 2 into what is the formula? N a to the power n minus 1. So in place of a I have a plus 2. So 3 by 2 into a plus 2 to the power 3 by 2 minus 1. This is gonna give me 3 by 2 into a plus 2 to the power half. Right? Alright. So now we are gonna take question from existence of limits. Alright. So we have this very important question over here. We are given that f of x is equal to a plus bx. A plus bx, okay, when x is less than 1, 4 when x is equal to 1, b minus ax when x is greater than 1. Okay, also we are told that if limit x tends to 1, f of x is equal to f of 1, a and b can be what? Okay, acha, so please see, limit x tends to 1, f of x is given to us as what? F of 1. What is f of 1? F of 1 is 4. Now limit x tends to 1, f of x is limit x tends to 1 minus f of x. Okay, for a limit to exist, the right hand limit and left hand limit must be equal, right? And this is going to be what? 4. Now you see 1 minus, when x is lower than 1, what is the value of function? It is a plus bx. So I'm going to write this is limit x tends to 1, a plus bx. And when my x is bigger than 1, what is the value of function? It is b minus ax. This is b minus ax equal to 4. So now what I'm gonna do is I'm gonna equalize the first limit with this one and then this one with that one. Okay, so limit x tends to 1, a plus bx is equal to 4. This will give me a plus b equal to 4, and then limit x tends to 1, b minus ax equal to 4. This is gonna give me b minus a equal to 4. This is equation 1, that is equation 2. So if I add equation 1 and 2, okay, equation 1 plus equation 2, a and minus a will cancel out, b plus b is 2b, 4 plus 4 is 8, and what? B is equal to 4. Okay, my b is basically equal to 4, right? So if b is equal to 4, then you tell me what I can do here. If you can plug the value of b back in your equation, so 4 minus a equal to 4, so a is basically gonna be 0, right? A is basically gonna be 0. Alright, so let us do some first principle questions. Okay, derivative using first principle method. So see, what is the if we have a function y equal to f of x, okay, f dash x, which is the called derivative, this is given as limit h tends to 0, f of x plus h minus f of x upon h, right? So let us take a example. Let us say that f of x is equal to tan x. Okay, so what I'm gonna do over here, I'll just plug in the value. Okay, what is my f dash x? It will be limit h tends to 0. It will be tan of x plus h minus tan x. Okay, and this will be divided by h. Now what I'm gonna do is this will be sine x plus h upon cos x plus h, okay, and this is minus sin x by cos x, okay, and then we will have this h over here, okay. So this is limit h tends to 0. I'm gonna write what? Cos of x plus h into cos x into h. This will give me sine of x plus h into cos x minus cos of x plus h into sin x, okay. So this is gonna give me what? Limit h tends to 0. Sin a cos b minus cos a sin b. This is gonna give me sin a minus b. So sin x plus h minus x, okay. On the bottom I have cos x plus h into cos x into h, okay. So this is gonna give me limit h tends to 0. I can simply cancel the x's out here. This is sin h upon cos of x plus h into cos x into h. Oh sorry, so this is what I can do, sin h by h, okay, this part over here, this gives me what? 1, okay. So 1 divided by cos of x plus 0, and this is again cos x. So 1 divided by cos square x is gonna give me what? Sec square x, okay. So sec square x is my answer, right? Okay, next question. Let us take f of x is equal to square root of sine 2x, okay. So what is my f dash x gonna be? F dash x is gonna be limit h tends to 0 square root of sine 2x plus what? You see, if it is what? If it is f of x is 2x, f of x plus h will be x 2 times x plus h will be 2x plus 2h, right? Minus square root of sine 2x, okay, and on the bottom I have this h over here. Firstly, what you do, you rationalize this stuff, okay. So if you rationalize, we'll have sine of 2x plus 2h minus sine 2x, okay. On the bottom I'm gonna have h times square root of sine of 2x plus 2h and plus square root of sine 2x, okay. If you apply sine c minus sine b on the top, you are gonna have 2 cos of 2x plus 2h plus 2x upon 2, and then sine of 2x plus 2h minus 2x by 2, and on the bottom we have this h and the denominator part over here, sine of 2x plus 2h plus square root of sine of 2x. Now you see, this is limit h tends to 0. This is gonna give me 2 cos of, see, 2x plus 2x is 4x, 4x plus 2h, right? So 4x plus 2h, okay, right? Also, if you can take 2 common, we will have 2 times 2x plus h upon 2, and on the bottom side I'll have what? Sine. This will cancel out. 2h upon 2 is simply h, okay. So this will be h and then square root of sine of 2x plus 2h plus square root of sine 2x. Now 2 and 2 cancels out. Sine h upon h, okay, this part over here, okay, if you just highlight this sine h upon h, this is gonna give me 1, okay. Then we have this 2 over here, cos of 2x plus 0, which is simply cos 2x, okay. And then this will be what? Square root of sine 2x plus 2h, okay. Sine 2x plus 2x is gonna give me what? Sine 2x only, because h is 0, and again square root of sine 2x. So I'm gonna get what? 2 cos of 2x divided by 2 times square root of sine 2x, okay. So this 2 and 2 gonna cancel out, so I'm gonna have cos 2x upon square root of sine 2x, okay. This is gonna be my answer. So the next question I have to see, if you have f of x is equal to sin x cos x now, So what will it be? F dash x will be limit h tends to 0. This is gonna give me what? F of x plus h minus f of x divided by h. Okay, so this will be limit h tends to 0, sine of x plus h cos of x plus h minus sin x cos x divided by h, right? So what I'm going to do is I'm going to create the sine 2a formula. So I'm going to multiply both top and bottom with 2. 2 sine x plus h cos x plus h, and over here I'll also 2 sine x cos x, okay, and on the bottom 2h. So you would know from your trigonometry identities that 2 sine a cos a is what? It is equal to sine 2a. So this limit over here, will reduce to 2 sine a cos a is sine 2a, so this is sine of 2x plus 2h, right, and minus sine 2x. On the bottom I have 2h, so this is gonna give me what? Limit h tends to 0, 2 cos of 2x plus 2h plus 2x by 2 sine 2x plus 2h minus 2x by 2, and on the bottom I have this 2h over here. Okay, 2x minus x gonna cancel out. Okay, I can also cancel this 2 and that 2, so we will have limit h tends to 0, cos of what? 4x plus 2h by 2. This is sine of what? Sine of 2h by 2 is simply what? H. Okay, and over here I have this h. So I'm gonna get what? I'm gonna get sine h by h will become 1, cos of 4x by 2, this is cos of 2x. Okay, so cos of 2x is the answer. Okay, now you would know that f dash x is what? F dash x is limit h tends to 0, f of x plus h minus f of x divided by h. Okay, likewise what will be f dash c at any point c? This limit h tends to 0, f of c plus h minus f of c divided by h. Okay, so you see we have this question over here. We have to find the derivative of 99x at x equal to 100. Okay, f of x is equal to 99x, and we need to find the derivative. Okay, derivative at x equal to 100. Okay, so f dash 100 is gonna give me what? F dash 100 will gonna give me limit h tends to 0, f of 100 plus h minus f of 100 divided by h. This gives me limit h tends to 0. This is 99 into 100 plus h minus f of 100, that is 99 into 100 divided by h. So this will be limit h tends to 0, 99 into 100 plus 99 into h minus 99 into 100 divided by h. This and that cancelled. Okay, so basically my answer is what? I can also cancel the h's out. Okay, so this will give me limit h tends to 0, 99 h by h. Okay, h and h cancels out, so I'm gonna have what? I'm gonna have simply 99. Okay, yeah. Alright everyone, please check out these questions. Okay, so I hope you know what is product rule and quotient rule of derivatives. Okay, d by dx of u into v, that is what? U dv by dx plus v du by dx. Okay, so if you have d by dx of, let's say, x to the power 5, okay, x to the power 5 into sin x plus cos x. Okay, what I'm gonna do is I'm gonna treat x to the power 5 as u, okay, and this as v. So what I'm gonna do, I'll take x power 5 outside and I'm gonna take the derivative of sin x plus cos x, and then I'm gonna take sin x plus cos x out of the way, and I'm gonna differentiate x to the power 5. So this is gonna give me x to the power 5. Derivative of sin x is cos x. Derivative of cos x is minus sin x. This is gonna give me sin x plus cos x. Derivative of x to the power 5 is 5x to the power 4. Okay. Yeah. Then next is quotient rule. What is quotient rule? D by dx of u by v. This is v squared. Okay. V goes out, du is differentiated, minus u comes out and v is differentiated. Okay. So please see d by dx of 1 plus sin x divided by 1 plus cot x. Okay, so I'm going to square the denominator. 1 plus cot x is going to get squared up. Okay, 1 plus cot x will come outside, and I'm going to differentiate what? I'm going to differentiate 1 plus sin x. Okay, then I'm going to take 1 plus sin x outside. Okay, and I'm going to differentiate 1 plus cot x. Yeah, so you see this is what? 1 plus cot x. Okay, I'm gonna write 1 plus cot x, then d by dx of 1 plus sin x is what? It is simply cos x. D by dx of cot x is what? Is simply minus cosec square x. Okay, and on the bottom I have 1 plus cot x. You please do the simplification. Okay, you can open up the brackets and solve. Okay, I'll just explain chain rule once. Okay, so what is chain rule? Chain rule is d by dx of u power n. Okay, firstly you differentiate u as per the exponent rule, and u to the power n minus 1, and then you differentiate u with respect to x. Okay, in place of u basically you can have anything. Suppose you have d by dx of 4x plus 7 to the power 9, so this will become what? 9 into 4x plus 7 to the power 8. Okay, now I'll multiply this with the derivative of 4x plus 7. So I'm gonna have 9 into 4x plus 7 to the power 8, and the derivative of 4x plus 7 is what? Simply 4. So 9 times 4, this is gonna give me 36. 4x plus 7 to the power 8. Okay. Acha. Next, what I'm gonna have? I'm gonna have let's say d by dx of sine cube x. So what you do, you treat sine x as u. So this is gonna give me 3 sine square x, and then d by dx of sine x. So this is gonna give me 3 sine square x into cos x. Okay, yeah. So there is another very important question of that I missed out of first principle, which is there in the miscellaneous of NCERT. So we have f of x is equal to cos of x minus pi by 8. Okay, now what will be f dash x? F dash x will be limit h tends to 0 f of x plus h minus f of x divided by h. So this is limit h tends to 0 cos of x plus h minus pi by 8 minus cos of x minus pi by 8 divided by h. So what I'm going to do is I'm going to apply cos c minus cos d. So if you do so, we will have minus 2 sine of um, c plus d by 2. Okay, so x plus h minus pi by 8 plus x minus pi by 8. Okay, c plus d by 2, and then sine c minus d by 2. So x plus h minus pi by 8 minus x and then minus minus plus pi by 8 divided by 2. Okay, and at the bottom I simply have this h over here. So this is gonna give me limit h tends to 0 minus 2 sine, you see x plus x is gonna give me what, 2x. Okay, 2x plus h minus pi by 4 divided by 2, and this will give me sine of x minus x gone, minus pi by 8 gone. So I simply have what, h. Okay, sine of h and then by 2, and this is what, this is h. Okay, so since we have sine, see, please see, we have sine of h by 2, so I need h ke niche I need out 2 as well, right? So I'm gonna just divide and multiply with 2, so this part becomes 1. Okay, cancel the 2's out here. Okay, so I'm gonna have minus sine of 2x, this h is simply what, 0, minus pi by 4 upon 2. So if you split this stuff, minus sine 2x by 2 is x minus pi by 8. Okay, this is the answer. So thank you everyone, please check out all the questions. Okay, we'll meet in the next video.